Hi, I'm Liz Sneddon. Let's have a look at linear combinations of discrete random variables. So linear combinations come in this form here. A times x, which is your variable, plus b. So we've got a constant a that we can multiply by, and or we could have a constant b that we're adding or subtracting to our variable. So when we come to calculate the new mean and variance of this linear combination, we need to take those constant values into account. So when I'm multiplying by a constant, then with my expected value I also need to multiply by that value. If I'm adding or subtracting an amount, then I will add or subtract that amount to my expected value. In terms of the variation, whatever the value that we are multiplying our linear combination by, then we are going to have that as a value squared for when we do the variance. And the reason for that is because our variance is our standard deviation squared, and so this is where the squared part comes from. Then we can also, if we have an amount that we're adding or subtracting, you'll notice that's not in the variance formula at all. And the reason for that is, if I give you a visual here, say I had a normal distribution. If I wanted to pick that up and move that over by 3 units, that's not going to change how spread out my data is. It's just going to simply change where the centre and the start and end point is, but it's not going to change the spread of the data. And that's why any constant that we add or subtract isn't going to affect the variance. As a note, calculate your variance first, and then you do your standard deviation.